what is MLOps. Now, a general understanding of MLOps is that what you will be learning. You will be learning set of practices and the tools aimed at operationalizing and scaling machine learning models in production. Okay. Now, what do you mean by set of practices and tools? What do you mean by operationalization? And what do you mean by scaling machine learning models? If I have to put a one line, what is the main work of a ML engineer or a ML engineer is they will accelerate ML and AI development and deployment. Okay. First. Second is they will collaborate between data scientists and engineering teams. Okay. Third is they will implement what we call CI/CD pipeline. Many of you are from DevOps background. You may understand it better, but we will also learn about this. Continuous integration and continuous deployment. They will ensure proper training, proper monitoring, and validation of the models. And lastly, they will enable governance to maintain model quality. Okay. So these are textbook references of what is the role of a MLOps and a ML engineer. Okay. I know many of you have asked already these questions, how they will do it. So that part we will learn. But how many of you are comfortable with the term of ML and AI first of all? So this is textbook. I've just printed what is textbook definition of a MLOps or ML engineer. But we will also understand the how part of it, how they do it, why they do it, what is the difference, how they collaborate. We'll try to bring that layers in, but I will bring it slowly, right? Now, yes, many of you have mentioned. So again, I'm asking how many of you are super comfortable with the terms AI, ML, DS, Gen AI, LLMs, these five terms. Also, I think, yeah, there may be deep learning. Yeah, I think these should be enough. The six terms, how are you all comfortable with? Okay, so many of you have mentioned that you may want to understand them. I request all of you to be interactive in today's session. I'm going to lay a base. I'm creating a small foundation, one foundation for all of you, so that you understand why the course is designed the way it is and what are we planning to do and where you will be at the end of this course. Okay. So now let me give a brief idea of these terms before we move forward. So AI obviously is artificial intelligence. ML is obviously machine learning. DS is data science. Gen AI is generative AI. And LLMs are large language models. And lastly, DL is nothing but deep learning models or deep learning. So essentially, if you ask me, of all these terms, the most broadest term which encompasses all the terms is the word AI. So suppose this is a circle, this is a universe, then the broadest term among this is AI. Is it clear to everyone? So AI is the broadest term or broadest field. And what does it deal with? It deals with something which we have heard, and the word itself is mentioning that artificial intelligence. I think all of you may have heard this. So it is artificially creating your brain. So mimic brain. Which brain? Not animal brain or any other animal brain, but human brain. Mimic human brain, that is what AI is. The better term or more technical term will be human brain, but in terms of intelligence. So I can also replace the word with brain with human intelligence. So if you are able to mimic human intelligence, then that is called artificial intelligence. Now, what you can do using human intelligence, you can do reasoning, learning, planning, problem solving. All the things can be done using AI. Whatever humans do, you can also do it. So what you can do, learning, reasoning, planning, for example, planning and problem solving. All these things AI can do for us, but how do they achieve this? They achieve this by doing something called machine learning. All of you? One of the ways I can mention here, say one of the ways to create human intelligence synthetically, that is why it is called artificial, is machine learning. How many of you understand this? So if I have to draw here, what I will do, I'll plot something called as machine learning. So if I have to plot it, I'll plot with a dark green, say something like machine learning. So machine learning, subset of AI. How many of you are understanding what I'm saying? So what does machine learning mean? As the word itself say, teaching machine with data. That is what is basically machine learning. Okay. Now, this is where your term is coming, MLOps, which is machine learning operations. Okay. So before we go into the operation part of it, etc. So essentially you need to understand the first point, which is types of machine learning, which is what? How can you teach the machine? So the question is, how can you teach machine? Now there are various ways to teach machine. For example, one is called supervised learning. Second is called unsupervised learning, and third is called reinforcement learning. RL, reinforcement learning. Okay, these are generally the three ways by which you can teach a machine. How many of you are understanding what I'm explaining? Okay, we will now later understand. I will show you later what is supervised learning, what is unsupervised learning, what is reinforcement learning. But your whole job now after this coursework will be to operationalize these different types of machine learning approaches so that we can create AI. Okay. Now, for understanding what you need to operationalize, we will have to understand the life cycle of machine learning. How do you teach a machine? That life cycle should be clear to all of you. Once you are clear about that, you will understand your role of what to operationalize, what to automate, what to scale. Am I making sense to all of you? Ram, can you give one more example of AI? So AI, for example, all the chatbots, self-driving cars, recommendation systems, face recognition systems, all this is nothing but AI. So for example, if you're using Google Maps to go from point A to B, instead of human intelligence, you're depending on the data and science of that analytics which Google Maps has done. You're depending on that. Also, your smartwatch, they take a lot of data and then they crunch and give you, say, some predictions on your heart status or, on your heart health status. All these are nothing but AI. AI is doing all this job. You're smart, everything is smart. Smart electronic products, all these are using AI. How do we create AI? We use machine learning for that. Now, the third term I want to come in machine learning, with these terms we will go in detail one by one and you will learn how to operationalize them in this coursework. Okay. Now, how can you teach machine? You require these different types of learning: machine, supervised learning, unsupervised learning, reinforcement learning. Now, if I have to give you one idea that these learning, like for example, if I'm teaching you, how do I teach you? I'm teaching you with examples. I'm teaching you with presentations. So there is a lot of process. I will teach you with hands-on session, with some demo session. So these are some of the ways by which I teach you. And then you will learn about it. You will practice and you will learn. Similarly, for teaching machines, we have something called algorithms. All of you, can you write this and send it to me? Algorithms. What are algorithms? We'll come to it. Okay. So algorithms are what we call mathematical models. Mathematical models or formulas. Okay. So for example, if I ask you how much time it takes you to reach office, all of you, can you answer this question? How much time it takes you to reach office? So various of you have answered, ranging from say 10 minutes to 1 hour, 60 minutes. Now, how did you answer this? So you may have used something called the average model, the most simplest model. Every day it does not take you 30 minutes to reach office. Sometimes it takes you 31 minutes. As one of you said, depending on traffic. Some days it may take you 40 minutes. Some days it may take you 25 minutes or 20 minutes. But on an average, it takes you to reach 30 minutes from your home to your office. So what you have calculated mentally is based on your historical data, based on your historical data of visiting your office, you used a model, a mathematical formula, which is the average model, and you answered this question. How many of you are understanding what I'm explaining? The key terms here are historical data from which you have learned, and then you have answered the question that, okay, it takes me typically 30 minutes to reach, and for that you may have suggested the average time. Am I correct, all of you? Does it make sense? Similarly, in order to teach machine, you have historical data and you are teaching the machine. You have used which model? You have used average model, but now with machine, we can use algorithms which are more complex than average model, and then it gives you the output. Am I making sense to all of you? Yes or no? Those who are especially new to these terms. So machine learning are different types, and these different types are essentially having different algorithms, okay, which learn from the historical data. Okay. So now I hope this is clear. AI is there, machine learning is there. Now these algorithms, okay, all of you are typically of consisting of different mathematical models and one set of algorithms. All of you, I'm using one more technical term. One set of algorithms are based on something called neural models. Okay, neural models, and these models and this grouping of algorithms is called deep learning. So what I will say is, if I have to explain you all simply, this is machine learning. Machine learning consists of different algorithms. One set of algorithms are based on neural networks or neural models, and these models are coming under what we call deep learning. And then other set of machine learning models are typically called classical ML, or are based on, let's use that only, classical ML. Okay. So one way to teach machine, what is the job of machine learning? To teach machine using algorithms. One way of teaching machine is using the neural network algorithms, and that sect of learning is called deep learning. So essentially, if I have to draw here, deep learning is again a subset of machine learning. Am I making sense? Yes or no, all of you? I hope it's not confusing. Do let me know. Okay. Now we'll come to the term Gen AI. So Gen AI is a subset of deep learning, which is Gen AI. And now what has happened? This piece of teaching machine using deep learning has become so evolved, has become so strong that you can now, based on these deep learning models, they have created these models, what we call the Gen AI models, generative AI, as the name itself says, that it learns from the historical data, and then it can the new shift it has done now is it can start generating own data. How many of you are able to understand why it is a watershed moment in human life? Is because till now AI was used mostly for predicting things. For example, what will be the prices of a particular stock price of a stock? What will be the whether it will rain today or not? But it was not good in, say, understanding human language, understanding context, understanding emotions, and also generating new content. What it could generate was what it has learned. It's something like humans say learn ABCD. It learns alphabets and then it starts writing poems. Previously, creating new poems, etc., was not what Gen AI could do very well. But with these models based on deep learning, it is able to generate AI, or it is able to generate intelligence. That's why it is called Gen AI. So essentially, Gen AI is that part of AI which can generate new content using what it has learned. Now, what are these models based on? The generating AI models, they are based on deep learning concept, which uses neural network or transformers in order to create new content. Okay. Now, these models which generate AI, they are generally very large language model. Okay. They are very large language model. So Gen AI can interchangeably use, though technically not correct. But for now, let's take this as an understanding that LLMs, large language models, are used to create or generate AI, generate intelligence. So I hope the picture is clear to all of you that we have AI in which one of the subpart is machine learning, in which one of the subpart is deep learning, and in that we have some LLMs or generative AI models, what we call, yeah, something like this. AI is there, machine learning others. Machine learning has deep learning and other classic ML algorithms. Deep learning have subset of large language models, and they can create or generate AI based on deep learning. Am I making sense to all of you? Gen AI is a concept or a tool, is a generic term where you're generating AI. That part of AI is subset of AI is called generative AI. We use LLMs, large language models, which are based on deep learning architecture to create or generate AI. Okay, so now I'm going to give you all a quiz. Some part of this quiz you will have to search for answers. What is the primary goal of machine learning? All of you. Store large data set, hard code rules, learn from data to make predictions, and visualize data. What is the nearest answer? Yes. So the answer is C, that we want to learn from data to make predictions. So this is what, or teach a machine to make predictions. And how do we teach a machine? We learn from the historical data. So this is the correct answer. For which of the following is not a type of machine learning? Spreadsheet analysis is not machine learning. These three, I had listed it earlier: supervised, reinforcement, unsupervised. We will be learning this later. Don't worry. Okay. We will be learning this in some time. What does a data scientist primarily do? Repair hardware, obviously no. Clean and analyze data to extract insights, yes. Design websites, no. Only write Python code, no. So the role of a data scientist is to do what? Clean and analyze data to extract insights. What is the role of a MLOps engineer in that case, all of you? The role of a MLOps engineer or ML engineer will be to operationalize this. Okay. Machine learning guys will do what? They will take the work of data scientist and operationalize it. Okay. We will learn also more onto it. I'll bring those layers also. Which algorithm is commonly used for classification task? So this is what a data scientist question is. Okay, so generally ML engineer may not know about the algorithms, but it is good to know about them. Okay, what distinguishes deep learning from traditional machine learning? It uses decision tree, it cannot handle larger, so this I have already explained you that neural networks or neural models are used with deep learning, and that is what separates it from classical ML. Which is the following is a popular case of generative AI? Image generation from text. You're generating new things. That is what is generative AI. Large models like GPT are typically trained on large-scale text data. So a lot of text data are used for training GPTs. Which of this is an example of generative AI model GPT-4? This algorithm this is an LLM which is generally used for generative AI. Which of the following combines coding, statistics, and domain knowledge? So this is data science. Transformer used in LLMs are best known for their role in image compression, text understanding, and generation. So LLMs are best known for text understanding and generation. Deep learning often requires more data and computational power than traditional machine learning. So this is again a data scientist question. The answer to this is true. Why it is true, we can understand. It's a data science question, but yeah, because deep learning models have more parameters, they require more data to be trained. Generative AI can only create text, not images or video. The answer is false. Now you know that it can do everything, images, videos, everything. Data science is only about building ML models. The answer is no. There are other jobs also data scientist does in terms of statistical analysis, etc. LLMs use attention mechanism to understand context in language. The answer is true. Supervised learning requires labeled data. This is again true. Question related to data science domain. What are the three main types of machine learning? Supervised learning, unsupervised learning, and reinforcement learning. Name two popular deep learning networks frameworks. So TensorFlow, PyTorch, they are popular deep learning frameworks. TensorFlow from Google, PyTorch from Meta are popular deep learning networks. What is a loss function in ML? You can ignore this question for now. Give an example where generative AI could be used in real life. I think all of you are using it. Like for example, creating your resume or learning new things, etc. How is a data scientist different from a machine learning engineer? I think this question I can answer. A data scientist will think about what? Will think about extracting insights. Okay. Will think about what? Extracting insights, or will think about teaching machines with algorithms, creating the best machine learning model, creating the best ML model. Whereas a MLOps engineer or a ML engineer will just focus on deploying and scaling the models. Is this clear to all of you? Yes or no? Am I making sense with this simple definition? I hope this was useful to all of you. Yes or no? So this is how I plan to take the sessions also, where we keep on learning topics and then we keep on layering over it, do hands-on, do some quizzes so that I can, reiterate what we have done. So that is how I also plan to. Okay. So now I'll give you one assignment and then we can take a break. What I want all of you to do is list all the major LLMs being used currently. So you have to name all the major large language models being used currently. Okay. So you have to list them. OpenAI, ChatGPT, Anthropic, Claude, Gemini, Mistral Large. These are the community-driven open series. What about Perplexity? There is something called Perplexity. I don't know if you have heard about it. Is it a LLM? It is a wrapper for using different LLMs like ChatGPT, Claude, etc. Correct. So I hope you're getting the idea why I asked this question. So Perplexity is the product. Backend of it is using different LLMs which are GPT, Claude, etc. I hope this is making sense to all of you. It itself is not an LLM. These are all LLMs. OpenAI, GPT 4.5, this is a model. Gemini 1.5 Pro. In fact, if you know, ChatGPT is releasing a new model. So if you see, in August 2025, GPT-5 is going to be released. GPT-5 is coming. It is most advanced language model yet to be released in August 25. And people are saying that this will be again a major shift. It has something called AGI. So people are worried, with this, a lot of jobs will be at more, more endangered. In fact, Sam Altman, the owner or the CEO of, I think he's the CEO, yeah, he's the CEO of ChatGPT or GPT. And then, he's saying that all the jobs will go. That is his prediction. Yep. Okay. So not to give you all anything, but this is how the world is moving. And we are in that field. We should start thinking on those lines also. Perfect. So I'm happy that most of you are now understanding the terms. New terms that I need to further go into detail is supervised learning, unsupervised learning, and reinforcement learning. Now, before I do that, first question was, what is MLOps? I think this is answered. Machine learning operations. How can we use in cloud container platforms? So, what is this question related to, all of you? So, this is one of the tool. So, if you remember the basic definition or the role of a ML engineer I have mentioned here is to deploy at scale, deploying and scaling the model, creating a operation. Now, can you all understand that how can we use in cloud container platform? First of all, you need to understand why is this required. This is required because cloud container platforms, those who don't know, they help in scaling or ensuring that there is robustness in the deployment. So cloud container platforms, in this course you will be learning one of the tool called Docker, in which we will learn how to deploy machine learning models. Okay, and once it is Dockerized or containerized, all these terms we will understand in detail later. I'm just giving a precursor here. So we will learn these tools. But I hope the idea is clear. Your question underlying thought is clear. Why we are learning it? Because we want to deploy at scale. And as a machine learning engineer, your job is to do that. And this is one of the tool by which you can do that. Dockerize it and then deploy it in a cluster. You will have to learn these skills. So not only Docker, we will learn more other ways to deploy it, like using APIs, or if it is non-production, then how do we create a quick UI and deploy it? I will be also teaching you those skills. Making sense? Now, these are the some core questions that we can come into. What role does MLOps play in reducing and speeding up experimentation? So before that, we will have to learn the life cycle of a machine learning operation. How does MLOps bridge the gap between? This also we will understand. So these are three core questions we will come back to. Can I move forward? Is it getting too theoretical now? Okay, let me ask you. So let's try to hit the core questions. So what is supervised learning? So in this, suppose let's open one of the data set. Okay, let me open one of the data set. So all of you, can you note here that these are A to I? Okay, these columns, we call it as features. All of you, can you write this? These are features. So what are the features in this data set? All of you, can you name them quickly? So pregnancies, glucose, blood pressure, skin thickness, BMI, diabetes, pedigree, age and outcome. So these are what? Features. Now in features, we have something called input features and output features. Output feature is also known as the target feature. Okay. Now here, what is the input feature? So suppose I tell you that I am telling you as your maybe, as someone who is giving an assignment, I'm telling you that you use this as input feature, A to H as input feature. So suppose I tell you that use A to H as your input feature. So in this case, it would be up to, I think, age. Okay. And your output feature is what? Your output feature is your outcome. So essentially, if you look at this problem, what is the problem? You are using the inputs from pregnancies to age and you are predicting whether the person is having diabetes. Yes or no? How many of you are able to understand my language? Is it making sense? The outcome is yes or no means 1 or 0. Okay. So now this kind of problems, this kind of problems where the target variable or feature is defined is known as supervised learning. How many of you are understanding what I'm explaining? Is it making sense? Yes or no? Okay. Now, why supervised learning? To explain it to you all, suppose you are teaching a nursery student. You're teaching, say, student of grade 1 or 2. You will explain them, for example, addition by showing examples, or you will just tell them that learn addition. What will you do? These are two approaches. That this topic you will teach them with examples and then you will test them, or you will just tell them that you learn addition on your own. You will take the first approach where you will teach them with addition. This approach you can use with, say, a college student. So this way of teaching, where you're showing examples, you're defining things, and then you're testing them, this is known as supervised learning. Okay. Now, supervised learning is also of two types. One is regression and second is classification. So when your target variable is a continuous number, for example, if I ask you to predict the exam score, say between 0 to 100, it is a regression problem. But if I say the target variable is where you have categories in your target, for example, predict the exam grade, which is A to D. So this is a continuous prediction you have to make, and this is a categorical prediction you have to make. So they are known as classification and regression. So if I have to make a chain, it would be something like this. So you have machine learning. In machine learning, you have something called supervised learning, where your target variable is defined. And in supervised learning, you have regression and you have classification. Yeah. So now tell me, what kind of machine learning models are these objectives? Predict exam scores based on study hours. Is it supervised, unsupervised? If it is supervised, what type of supervised learning it is? Second is recognizing handwritten digits and diagnosing disease from patient data. Whether the person has that disease, yes or no. So for example, diagnosing cancer. So this is recognizing handwritten digits. You have first trained the model, and then you are asked to recognize handwritten digits, what kind of model it is, and predicting exam scores. All of you, please answer this question. So this first one, predicting exam scores, is SL, supervised learning, provided that we have taught the machine learning algorithm with samples. And then the target variable is defined exam scores. So it is supervised learning. And then it is of what type? Regression. Similarly, recognizing handwritten digits, which has been trained on a model, then supervised learning. And because handwritten digits are 0 to 9, they are categorical. So this is a classification problem. And diagnosing disease from patient data, again, is a supervised learning, because you have to, what your target variable is. And because it is again having cancer, yes or no, it's a classification problem. I hope this is clear to everyone. Making sense? You just have to focus on the target variable. What kind of target variable you have to predict. So for example, if I ask you, predict the selling rate, okay, of a house based on area, size, etc. What is the prediction going to be? Is it going to be some numerical number, or is it going to be yes or no? So I have asked you, predict the selling rate in terms of, say, dollars. Is it a continuous number that it will be some number, or will it be a classification, a yes no kind of problem, or is it a category? So if it is a continuous number, which you are predicting, and not a categorical number, which you are predicting, yes or no, yes can be 1 or 0, so it's still a number, but there are categories there. It's not 0.1, 0.2. So if it is a continuous number like a price, it is called regression problem. And if it is a categorical where you have to just categorize your data into yes or no, cancer or not a cancer, diabetes, yes or no, then it is called a classification problem. Is it making sense? Okay. Machine learning, supervised learning, regression and classification. Regression, let me show you a data set. So suppose I ask you, okay, let me show a data set that would make it easier. So all of you, suppose you have been given this data, salary, bond, these are the features. So many features, how many passes they made. For every footballer, they have so many features which a footballer is mapped with. So you can imagine each footballer, they map these information, how many goals, how many assistants, some parameters they keep on updating. Now, if I ask you to predict based on these performance, say these input features B to B onwards, you have to predict salary. So Shijit, what kind of problem is this? What are you trying to predict here? You are trying to predict the salary of a footballer, how much, say like in IPL, how much you should bid for a player, how much a player is worth. Suppose you are asked to create a machine learning model for that based on how many runs, wickets, fielding, etc. Then the salary is the prediction. So is salary a continuous number here or is it a categorical number? So it's a continuous number. So what kind of problem this becomes? It is a supervised learning because the target variable is defined, and it will be a regression problem because it is a continuous number. It is ranging and it is changing for each player. Now I'm getting it. If there is a lot of data to be analyzed for the result, it is regression. No, it doesn't concern what data you have to analyze. It is wrong what you're thinking. What you need to just see is what is your prediction. Your prediction here is a continuous number which is ranging from anywhere, say between $0 to $1 million, for example. That's the salary a person can have. Now, if it is such a problem where you have to predict a number, that becomes a regression problem, a continuous number. I hope this is clear now. So you just need to focus on the target variable, whether the target variable is a continuous number or is it a categorical number. Okay. So I hope this is useful to all of you. Yeah. If not, don't worry. You can also read about it and I will also explain it with more data sets later. Currently, if it's okay if you understand at some level what is, I think most of you have understood it well, machine learning, supervised learning, regression, classification. Now suppose, now you understand that it can be a supervised learning regression problem, but then how do you teach the machine? Okay, how do you teach the machine? So for that, there is a operation, there is a way or there is a process by which we do it. Okay. Now my first question is, what would be the first step for you to create a machine learning model? So suppose I ask you, you have to create a model which predicts the price or the salary of a person, of a footballer. What would you require for that? So the first thing will be, all of you, first thing would be, very good, data collection. So I would say the first thing is defined in the question, but let's put it formally. The first would be, step one will be problem definition, which is very clear here. We want to predict what? Predict salary. And now you have understood it is a supervised learning regression problem. So that is your problem definition. The step 2 will be for you, essentially the first step will be data collection. So what you have to collect? You will have to collect the data from various sources, databases, API, etc. How many of you are understanding what I'm explaining? So in this case, suppose I give you this data. What is your data source? Quickly, all of you. So I have given you the data in the Excel. The data has been given to you in an Excel file. So your data source is what? Excel file kept in my machine, which I am sharing with all of you. Does it make sense? Yes or no? So if I give you a OneDrive to download it from, or if I give you a GitHub to download from, or if I give you a storage from where you can download, that becomes your source. And what is the format of the data? It is in a CSV format. But in real world, you may also have situation where you may get the data, say each column of the data, say for salary data is coming from different database. For example, salary is coming from one SAP HR module of SAP. Personal data of the footballer is coming from, say, another module of SAP. Say the football information about the player is coming from a data kept in, say, ESPN Cricinfo or ESPN, some app it is coming from. You are calling from some app. So I hope you are getting it. So you will do what? You will pull the data or collect the data from these sources and create your database. You will collect your data. How many of you are getting what I'm trying to say here? Is it making sense? Okay, perfect. So now I hope you are getting the idea that this, you may get this kind of data or you may not. You may have to work hard to get this data. You may have to work on a pipeline to get this data. So this is not exactly data engineering because you are not engineering this data. You are just pulling this data from a database. So this part of the job is called data collection, correct? Now in this data collection, sometimes you may have structured data like how we have the salary column, etc. Or sometimes you may have unstructured data. Suppose I ask you to download the catalog of a product. So it may be a story of a product. For example, what is that product about, what features it has? That becomes like a text data, that are unstructured data. So you may have to do both kind of data pulling. Okay. Now, generally, if you collect your data, once you have collected your data, what should be your next step? Will you start consuming the data directly? Yes or no? Or you will do some checks and balances on the data. So this we've called as the data pre-processing and cleaning. Data pre-processing and cleaning. So for example, your data may be corrupt. Your data may have lot of, say, zeros because it did not pull properly or there was issue in the upstream. Sometimes your data may have lot of null values. It may have issues of outliers, unnecessary mode, some data are bumped up or down. A lot of issues with respect to data quality will be there and you may have to look into it. So this step will be your next step in machine learning. Post you have cleaned your data, you have done your data quality checks. Step 4 will be something we call exploratory data analysis. Exploratory data analysis, EDA. Okay. So now exploratory data analysis. Here what we do, this is a typical data science step where the data scientist or the data analyst will do what we call data visualization. We'll try to understand what is the range of salary, what is the median of salary. We'll do a lot of statistical understanding of the data and we'll also do something known as correlation checks. For example, I'm just listing few of the steps. Okay. So these would be some of the steps in exploratory data analysis. The next step, step 5, will be what we call feature engineering. So for example, in this salary data set, there are a lot of text data. Can you see here? Lot of text data. So this is what I call corrupt data. NA, you can see somewhere NA is there. Sometimes you have minus, negative numbers. Maybe negative was not expected, positive was expected. So all this of analysis is what we call EDA. But feature engineering is that you need to say convert country, okay? Convert country into a numerical data. So for example, Canada is replaced with 1, USA is replaced with 2. Why do you do this? Why do you do this? Because machines do not understand text data. You have to feed them numerical data. So what you are doing here, you are converting your text data into numerical data, and that is what we call feature engineering. How many of you are getting what I'm saying? So like this, there are a lot of steps which are related to feature engineering. Okay, so what we will do for this data set, we will feature engineer, and post this, step 6 will be what we call model selection. Model selection. So what is model selection? Model selection is, what kind of problem is this salary problem? Supervised learning regression problem. You have select, now you will have to select which models we will use here. So for regression, you have various algorithms like linear regression, XGBoost, random forest. All these are data science models which a data scientist will use. So it is called model selection. Okay. So now what I want all of you to do is, I want to go up to step 12, but I think it will be too exhaustive for all of you. So before I end this today's session, I want all of you summarize the first 6 steps. Model selection. 7 would be model training. We'll come to that later. But yes, clearly define the output, predict, gather structured, unstructured data, fix missing values, outliers, visualize data, identify and build the most relevant input features of the model, and use algorithms to learn patterns. So, or I will say select algorithms to learn patterns from the prepared data. That's model selection. So the agenda for the next session, tomorrow's session will be, by the end of tomorrow's session, you should have basic understanding of what is MLOps and the tools required to be learned. Okay. And the whole MLOps life cycle. Okay. What needs to be operationalized, and then what are the benefits. So once we reach the end of tomorrow's session, you will have a good understanding of these questions. You will be able to answer these questions. What role does MLOps play in reducing and speeding up experimentation, and how it does it? How does MLOps bridge gap between data science, and how can as PMs track ROI and feature importance when ML models are deployed at scale? So these 3 questions you should be able to answer at the end of tomorrow's session. And also, partially or at a say a high level, you should be able to understand what you will be learning to become or reach that stage.